Welcome back. In this lecture, we're going to continue where we left off and go over a couple of more regular expression techniques. Let's head over back to the notebook. Here we are in the same notebook we left off last time. Previously, we actually showed you how to reduce this pattern using regular expressions into this pattern with quantifiers. One other thing I want to mention are the ability to actually grab separate groups. Currently, this entire phrase for the pattern is one solid group, but you can compile separate groups using parentheses. So I can use parentheses to actually separate these groups in between the dashes. So I'm adding parentheses, and now when I search for this pattern inside of the original text, which was my telephone number, and if I actually say mymatch.group, that groups together everything. But I can actually call individual groups starting at index position 1, and that's going to grab the first set that was inside the parentheses. So if I say group 1, it just grabs 888. You can see here, if I were to include the dash inside the parentheses and rerun this, group 1 would have been 888 dash. So this way, you can actually use the same character identifiers and the quantifiers as before, except now you can easily group things because maybe you only wanted the area code. So then you could just say group 1. Or if you wanted the last digits, well, that would be in group 3. And those would be the last 4 digits. So that's the ability to use groups. And if you want to group everything, you just don't provide a number and it groups all the groups together. Some additional regular expression syntax that I want to show you is the pipe operator. You can use the pipe operator to have an OR statement. For example, I can say RE search, and the pattern I can search for is man, pipe operator, woman. And I can say text is this man was here, and we end up getting a match on man. Or I could say this woman was here, and we end up getting a match on woman. So you can see here it'll work for either man or woman with the pipe operator. You can also use a wildcard character. You can use a wildcard as a placement that will match any character placed there. For example, I can say re dot find all, and I'll put a dot there for my wildcard, and then say at. And then I'll create some Dr. Seuss sentence, the cat in the hat sat. And if you run this, you can see it found cat, hat, and sat. Basically a wildcard and then AT. So CAT, HAT, and SAT. Keep in mind, the way this is currently working, you're only matching on one letter. So if you were to actually say splat at the end of this and run this, you would only get out LAT. You could then continue on messing around with quantifiers or identifiers or even more wildcards. So you can place multiple wildcards here, and it'll end up grabbing the space and then the letter, or in this case, it'll grab 2 letters before A, and so on. So again, a dot is a wildcard character, and you can combine it using this sort of grouping, quantifiers, or character identifiers. Next, maybe you're just interested in things that start or end with a particular type of character. Well, you can use the caret, which is above your 6 on your keyboard, in order to say starts with. A $sign signals ends with. So for example, I can say re.findAll, and I will say \D for a digit, and then a $sign. And a $sign again signals ends with. So I can say this ends with a number 2. And return back, and it's going to find where it ends with the number, and there we see 2. I could then also say caret here instead of a $sign, and that indicates starts with. So I could say 1 is the loneliest number, run that, and I get back 1 since it's starting with a digit. Now you should note that this is for the entire string, not just for individual words. To exclude characters, you can use the caret symbol in conjunction with a set of brackets. Let me show you what I mean by that. Let's create a much longer phrase and say there are 3 numbers, 34, inside 5 this sentence. Now let's imagine I wanted to get rid of all the numbers inside this sentence. What I can do is I can say re find all, and then I can pass in a pattern. So we'll say r and then quotes, and then I'm going to say closed square brackets caret for \d. So I have my \d, the caret, and when the caret is actually inside these square brackets, that's going to indicate exclusion. So I'm basically saying exclude any digits. So let's pass in our phrase, and you'll see there are, and then we just get spaces and then numbers inside this sentence. So it's actually no longer actually grabbing any of these numbers. We're excluding it with the use of these square braces or brackets and then this caret symbol. Then if you actually want to get the words all back together, you can add a plus sign here. And that's going to return back basically anything that isn't a digit. So we can actually use this to remove punctuation from a sentence, which is a common thing you have to do when working with natural language processing. Let's create another test phrase and say, this is a string, but it has punctuation. How to remove it? Question mark. So there's a bunch of punctuation here. Again, all I need to do is say re find all, and then start indicating what we want to remove. So inside these square braces, I'll have my caret, and then say exclamation point, period, question mark, and then say plus, and then pass in my test phrase, run that, and then I get to see this nice list. This is a string, but it has punctuation, how to remove it. So you'll notice right now it's a list of everything that isn't punctuation. So I'm using exclusion here. And if I wanted to, I could say my list is equal to this, and then I have my list here, and I can use the .join method off of a string in order to join this list together. So I could say join, and let's actually just say right here, join with a space. So I could say space, and that's going to join every item in this list with a space in between. So now I see this is a string, but it has punctuation, how to remove it, which now has successfully removed any punctuation from this test phrase. Main thing to note here is you have these square braces and the caret, and then this plus sign. And then anything inside these brackets after this caret, we're looking for exclusion. Now the last regular expression parameter I want to talk about is something we actually just saw, which is the plus sign, along with using brackets for grouping. So this plus sign, along with brackets, allows you to use grouping. Let me show you what I mean by that. By saying text, and the text string we're going to work with is only find the, we're going to say hyphenated words here. So hyphen words, where are the longish dash words? So let's imagine a situation where we want to find any sort of words that have this hyphen in it. Well, what we can do here is say re find all. So we're saying find some set of letters, a dash, and then some other set of letters. And the way we're going to word this here is actually going to be able to grab that period as well. So the way we do this is we say in square brackets \w, which if you refer back to your regular expressions notebook and start scrolling up so you can find the table, here we have the identifier \w, that stands for alphanumerics. So both letters and numbers will be picked up here. So this will grab inside square braces with a plus sign. This basically indicates grab any number of alphanumerics, so some group of alphanumerics. So alphanumerics is indicated by \w. The square braces with the plus sign indicates any number. Then what we want is a dash, and then \w, and then plus for, again, any number of alphanumerics. And then we're going to search that text. We run that, and it went ahead and find those words for us. And it actually didn't pick up this period because we didn't ask for punctuation. We just asked for alphanumerics, and a period doesn't count as that. So that allows you to actually grab anything with this sort of pattern. So hopefully you get the idea here. It's just, again, a group of alphanumerics, a dash, and then another group of alphanumerics. Notice that we didn't have to specify how long we expected either side of number of characters on the dash to be. Okay, so I know that's pretty complicated stuff, but remember, you should always be able to break down a regular expression using the tables that we provide here into its basic steps. You should also be able to use the example matches and example pattern codes with identifiers and quantifiers to actually build up what you want. And the main one that we're looking for here was this +1, which means just occurs one or more times. Okay, so coming up next is going to be your assessment to test your new skills. We'll see you at the next lecture.